Here's our problem for today. We have a magical frictionless roller coaster. And so what's happening is that with people at the top of the roller coaster, they're not moving, but they have a height of 15 meters. And they roll down and then back up. Again, no friction, no air resistance or anything. So they're at the top of this 5-meter hill. And then they go off the edge of a cliff and fall 10 meters below where we are measuring 0 from, so negative 10 meters. And I want to know how fast are they going right here. So that's V2. I'm calling this energy 2. And how fast are they going right here? Now, hey, just look at the problem. Where are they going to be going the fastest? E2 or E3? They're going to be going faster at 3. Yeah. Okay, so now let's work this. And if you're watching this at home because you were absent or something, please pause and try to work the problem on your own before you watch the rest of this. Okay, let's do part A. Excuse me. Well, since gravity is the only force slowing down or speeding this thing up, we can say that this is a conservation of mechanical energy problem. So E1 equals E2. Or you can say E initial equals E final. Now let me zoom out. Well, what is E1? Well, the only kind of energy it has up here is gravitational potential at position 1 is equal. But look at E2. It has gravitational potential energy there as well, but it also is going to be moving, so it has kinetic energy at 2. So what I can do is solve for K2. The kinetic energy at position 2 is equal to UG1 minus UG2. Does that make sense to everybody? I just subtracted this to the other side, expressed it like that. And now I think I'm ready to put in numbers or formulas. 1/2 m V2 squared is equal to, well, this is mgh1. mg, and what is h1? Let's just put it in. h1 is 15 meters. Minus mgh2. Well, what is h2? 5 meters. Now notice that in each term I have the mass, so I can cancel it out. I can divide both sides by the mass. And now I can just solve for V2. Well, let's do this. Let's go G, let's just factor the G out. We're going to multiply by 2. We're going to multiply by G. And then we're going to have 15 minus 5. And really what this is my change in height. And I'm going to take the square root. So this is going to be the square root of 2 times 9.8 meters per second squared times 10 meters. And I believe when you do that, you get 14 meters per second. Is that right? Okay. Any questions on that? Okay. Since there's no friction and nobody's pushing on it or anything, we're not adding or subtracting mechanical energy from this system. All we're doing is turning some of our gravitational potential energy, but not all of it because we still have some height, into kinetic energy, and then we can use that to figure out what our velocity is. Now part B. Well, again, there's no loss, so E initial or E1 equals E3. And so we'll just go through the same thing. That's UG1. All my energy here is gravitational potential energy is equal to the gravitational potential energy at 3 plus the kinetic energy at 3. So notice this is just like part A. I mean, let's solve for K3. Kinetic energy at position 3 is equal to UG1 minus UG3. Now let's do this. This is mg h1, which was 15 meters, minus mg times, well, what is h3? Negative 10 meters. We have fallen down. We are below where we were measuring our height from. So compared to here, our roller coaster car has negative gravitational potential energy. Now this is going to be equal to 1 half mv squared. So I can cancel out the, I don't want to rewrite the whole thing, so I'm just going to say that this is equal to 1 half mv3 squared, right? So I can cancel out the mass. And again, I'm just going to repeat what I did before. V3 is equal to, well, multiply both sides by 2g. And this is going to be 15 meters minus negative 10 meters. Well, that's really 15 meters plus 10 meters, isn't it? So that's 25 meters. So this is equal to 2 times 9.8 meters per second squared times 25 meters. And I'm running out of room, but I think when you plug all that in to your calculator, oh shoot, I had it written down. I'll just do it. Let's see, square root of 2 times 9.8 times 25, and you get 22.1. That's pretty fast. So, and does that make sense that you're going so much faster than right here? Sure it does. Gravity was able to do more work on you, was able to increase your kinetic energy by sacrificing gravitational potential energy, and so you're going quite fast. Okay, now there is a problem. Zoom all the way out here. Oh, I am. There is a problem on the test, almost exactly like this one. Do you see how to set it up? Okay. You start here. And then you break it, you know, mechanical energy is conserved. Now, what kind of mechanical energy do you have? Well, here it's all gravitational, but here it's shared between gravitational and kinetic. And then you know, 1 half mv squared, mgh, and then you just solve for your unknown. After that, it's algebra 1. Same thing is true here. If you just do what it says very carefully, and notice that this is negative 10, you'll get the answer. Okay, that is all.